Hello and welcome in this video where we are going to learn how to create a procedural map in a 2D environment using the Perlin noise, and hopefully we will create some caves as well as some overhangs if we can manage. Here it is, some overhangs as well. Let's see the scene view. The map will look something like this, and to create those overhangs and the caves, so the darker areas, we are going to use the Perlin noise function. Hi, I'm Peter and welcome to Sunny Valley Studio Tutorials. In this tutorial we are going to use voxel pack from Kenny Assets. Before we start, thank you very much to all my patrons. Thanks to you guys I am able to create those tutorials. If you want to follow along with this project, there is a link to the GitHub repository in the description of this video. You have a starter project here, and we have also full project, the packages per each video, the scripts, and there are commits. So if you do not want to write the code by hand, you can enter the video commit and you can copy the code that we have introduced in this video into your own files. Okay, let's go to Unity Hub and create the starter project. Create new and select the 2D template to create your project and import the package downloaded from the GitHub. Okay, when you're done, you should have something like this if you go to the scenes and open up the procedural 2D map scene. In the preset that I have provided for you, we have the sprites from the Kenny assets. I have also created the tile palette and tiles from those assets that we will use in the tutorial. And in the scene view, we have the main camera, and we have a couple of tile maps that I have pre-created, the background, ground, and the Perlin 2D, which we will use to explore how to create caves. And we have the canvas with 3 buttons so that we will be able to generate those maps and see how they differ. And we have also the block data script. It is in the underscore scripts folder. And this contains the references to the tile assets that we will use. So basically to the tiles that I have pre-created from the sprites from the Kenny assets. Okay. And this will be a series of 2 tutorials. In the first one, we are going to explore how to use Perlin noise, and in the next video, we are going to explore how to create caves and overhangs using the Perlin noise 2D. Since we will use the Perlin noise to generate our procedural map, let's explore what is the Perlin noise. So Perlin noise is a pseudo-random pattern of float values generated across 2D plane. Although we can create a 3D Perlin noise does not contain a completely random values at each point, but rather consists of waves of those values. Now this doesn't explain very much, so in the description I will link an article understanding Perlin noise, and Perlin noise is an extremely powerful algorithm that is used often in procedural content generation, and basically it generates this kind of wavy pattern in 2D that we are going to use, as well as we are going to use the 2D version of this to create our caves. As you can see, those black areas could be representing caves. But again, I would suggest that you take a look at this article if you want to learn more. So let's go to Unity and let's implement our Perlin noise to generate our 2D map. Okay, now first of all, we are going to use tile maps to create our map. So I want to have a script that will allow me to easily paint tiles on those tile maps. So let's right click, create in the scripts folder, and let's create a C# script, and I'm going to call it world renderer. And let's open this script up in Visual Studio. Okay, I will paste the content of this class. So we are going to use tile maps. So right click, quick actions, and say using Unity engine.tilemap's at the top to be able to use the tilemap class. We will have public tilemap, and we are going to get the ground tilemap, Perlin 2D tilemap, and background tilemap. Those will be used to create our map. Now we have some methods: public void set Perlin 2D, which will be used to set the concrete tile base, which we have in the script that I have created for you, the block data. It contains the reference to the tile bases, so basically the tiles that we can paint on our tile map. Now we are going to set the tile on the X and Y coordinate, and those are world coordinates. And to set the tile inside a tile map, we need to call our tile map name setTile, and we are going to call the tile map name world to cell, which methods convert the world position to the cell position in our tile map. and we are going to pass new vector 3 int x, y, and 0 as the z value, and the second parameter will be the tile that we want to place there. Now we have the same method set ground tile for the ground tile map, which is exactly the same, but instead of calling the Perlin 2D tile map, we are calling the ground tile map. And we have the same for the background, so we are calling instead the background tile map here. And next, we have two methods to clear our tile maps. So clear ground tile maps will clear the ground and the background, since those will be used together, so we are calling clear all tiles. And we have the second method, which only clears the Perlin 2D tile map. Great! So this is it for the world renderer. Let's save it. Let's go back to Unity. So now we need a class that will be actually generating our world. So let's right click, create a new script, and we are going to call it world generator. And let's open it up in Visual Studio. Okay. So again, I'm going to paste some code and we are going to explore what it does. So first of all, we will have a reference to our world renderer, and the block data to have access to the different types of tiles that we can place. Next, we will have a map length. So this is the length of our map that we will generate. And next we have the amplitude. Let me rename it. So amplitude is how high our Perlin noise return value will be. So basically, the math f.perlin noise generates the value between 0 and 1. So if we multiply it by 10, it will basically generate the values between 0 and 10. So this is the height of our map. Now, the frequency can't be 1, because if it is, the Perlin noise from the mathf library from Unity will return the same value every time. So we need to calculate the value between 0 and 1. So x can't be an integer. We will need to either subtract from it some value or multiply it by some frequency. So the frequency will be 0.01 in our case, and we are going to change it and we are going to see how it influences our Perlin noise. Now we have also the text mesh prefab. I have provided it for you. It will simply generate an object in our game view and we are going to be able to see the value of our Perlin noise. Next we have our getNoiseValue method that returns a float value, and this basically calls our mathf.perlin noise, which is a method that calculates the Perlin noise and returns a value between 0 and 1. So as I have mentioned, we are going to multiply each parameter, so each coordinate, by the frequency and multiply the result by the amplitude to rise our map to certain height. Next we are going to have the method that we'll call by pressing a button. This will be a generate map 1D noise, and this will generate our points between 0 and map length, and we're going to call simply var noise equals getNoiseValue for x as x parameter and 1 as y parameter. So basically it all depends on the x value. And when we calculate it, we are going to call createNoiseValue text, which will create a text object at positions x. Y will be the noise, and the float noise value will be the value that we are going to set our text to, so that we can see what is the value that was generated. And we are going to set the color of this so that we can maybe visualize what is the difference between each value. And this t.text sets the noise to string and it formats it to have 3 places after the comma to be filled with values. Great, so let's save it. Let's go back to Unity and let's set up our scene. Okay, so in the assets we have our text prefab, which is simply a text mesh, so we can place it in our game world. We are going to right click here and create a new object. Let's call it world, and we are going to assign here our world renderer, and to it we need to assign our tile maps. For now they are not important, but we can assign them so we have them all set. So Perlin noise, ground, Perlin noise and background, as well as we are going to drag here our world generator. We need to drag world renderer as well as the block data from our scene, from our hierarchy, and we should be good to go. Now, as I have mentioned, the map length will be 50, amplitude will be 1, frequency will be 0.01, and the text prefab, we need to set it. Okay, great. And we will want to go to our canvas panel and generate button. So this is the first button, and I have disabled the layers for the UI. Okay, so this will be the Perlin noise button. Let's assign to it our world object on click event, and I'm going to select world generate, and I'm going to select our generate map 1D noise. Let's press play. Now we should be able to press our Perlin noise, and we should see our elements of type text. And as you can see, those have the values between 0 and 1. Let me disable again the UI layer. And those are the values that our algorithm has generated us. So those are 0.46, 47, 47, again 48. So they go in a wavy form to 0.5 and so on. And at some point they will start to drop. So this doesn't show us a lot. Let's set the amplitude to something like 10 and let's press play. So now if we press Perlin noise, you can see that this started to rise because now our values have some height and they are not between 0 and 1, but rather between 0 and 10. Now this doesn't give us much room to play with it because we are spawning those text prefabs. So let's stop the game and let's modify our world generator in our scripts so that it places tiles on our tile maps. So let's open up the world generator, and instead of creating our text, we are going to create our tiles. So before we generate anything, we are going to call our world renderer.clear ground map. So we want to clear the ground tile map. And after we generate our noise value, we will want to floor it to be an int value instead of a float value. Now we can paste a for loop. So the for loop will be looping for y equals 0 and y less or equal than y coordinate, so the noise value. And for each position x and y, we are going to call world renderer set ground tile, and we are going to call block data dot dirt tile. So we want to set the dirt tile in all of those positions. So now we should be good to go. Let's save it. Let's go back to Unity. Okay, and if we select our block data and select our dirt tile, you will see that this is the image that we should be seeing. So now let's press play, and when we select the Perlin noise, it will generate us the Perlin noise. Now as you can see, it doesn't look very interesting. So let's select our world. Let's set the amplitude to be something like 50. So this is the height of our terrain. Let's click Perlin noise. So again, it doesn't look that good. So what we can do is play around with the frequency. So if we increase from this 0.01 to 0.1, let's generate the noise. And as you can see, there are much more hills here. So the frequency basically zooms in on those positions of the hills. So let's set it to be 0.09. Let's generate it. As you can see, those hills are getting bigger and they are getting wider apart. Let's select 0.05. And as you can see, we have now bigger hill, but they are more sparse. And when we select the 0.01, it will be this big hill. So we are zooming in very close to our noise function. So basically, that is what we can get with the basic noise function. But that's not exactly what we want. It doesn't look that good. We can change it back to 0.08, for example. And this does look okay, but I guess this is very repetitive. So we need to tweak it a bit to generate a really nice landscape. And in the next video, we are going to explore how we can use a multi-octave noise value to generate a bit better looking landscape. So see you in the next video.